Good afternoon to all the foundrymen and participants. First, first of all, let me thank Chennai chapter for organizing the today's webinar jointly with Andhra chapter, and I welcome all the participants to the today's webinar topic, lost form technology. Nowadays, it is a very widely used technology. Even since olden days, it is persisting and it is gathering further momentum nowadays. Uh, Even the small scale or the large scale uh, components, both the things, it can be made applicable. I think the Mr. T S Rao of Madras Engineering Industries Limited, he will be presenting the today's topic. And once again, I welcome all the participants to today's webinar. Thank you.
Thank you, sir. To begin with a brief introduction of our speaker, first thing is one of the most popular personalities in our foundry fraternity with a vast knowledge in this industry. Mr. T S Rao, he has done his diploma in ship design, masters in public personal management, MBA in TQM. He is certified lead auditor for almost all certifications, including PED. He's a Dale Carnegie trained leader, Lean Six Sigma black belt, and he's had almost 36 years of foundry experience in all processes, including sand, centrifugal, GDC, lost wax, lost foam, and replicas with all materials, including iron, steel, and copper alloys, with an hands-on experience in new product development. So, out of his multiple verticals of knowledge, I think he's going to just share us one particular lost foam technology with us. And he's traveled to almost 15 countries for supporting foundry suppliers, improving quality and productivity for them, and then developed over 2,000 products from APQP to PPAP. 20 years in Hinduja Foundries, Hyderabad, 1 year in Hindustan Motors, Kolkata, 2 years in Dakshin Foundry, Bangalore, 1 year in PT Castings, Hyderabad, 12 years in Armstrong Fluid Technology, Bangalore, and he is now the CEO of Madras Engineering. So I welcome you again, sir, and we should be all thankful for such a knowledgeable and experienced person taking this topic.
Thank you, Dinesh. Good afternoon, Foundry Fraternity. Thanks for joining us today for the presentation on last form technology. As we know, the last form technology is a ocean. So I'm going to touch a few drops of the ocean. I hope all of you can see my screen.
Yes, sir, it's visible.
Yeah, it's visible, sir. Visible, sir.
Okay, excellent. So we all, from the foundry fraternity, we know the various casting manufacturing processes. Start with the sand casting. Within sand, there are many processes. We know green sand, chemically bonded sand molding process. Under the chemically bonded sand molding, there is a cold box, there is no bake, air set, pep set, alpha set, and CO2. And coming to shell and hot box, and there is a V process. I think probably we'll have one more session on the V process, which is also very interesting, catching up in India as well. And further to the sand casting, we have metal molding processes. It is a centrifugal casting process. And again, in the die casting process, there are a couple of verticals, gravity die casting or permold. Permold is a popular name in the Europe. And high pressure die casting, low pressure die casting. And coming to the wax, there is a last wax or investment casting process. Coming to the foam, under the foam, again, there are three categories. There is a replicas, which is patented by CTI UK. And last foam, this is the subject we are going to cover. And next is a full mold. You can see the various casting manufacturing processes. I have not covered some more like a Hitchener process. There are many processes in casting manufacturing processes. Today, we are going to cover the last foam. Moving on to the introduction to the last form. Actually, the last form, if you all know the investment casting process, it is just the foam is replaced by the wax. That is a major difference between the investment casting and the last form technology. But one difference is in the last wax, the wax is drained and recycled, whereas the foam is melted away. The metal in, foam out. There is a major difference between last wax and last foam. And it is started 1956, but in India, it is early 2000s. It entered India, and there are a couple of very good foundries in India. Some of the foundries are doing very well, and they are global leaders today. These are the major steps of the last foam casting process. The first one is the product design to the process. This is very, very important. Unless we design the product to the process, we will not be able to achieve the desired results out of this process. Next step is the tool design and tool manufacturing, which is different from the conventional sand casting process. Third one is the casting process, tool design and manufacturing. And three major areas is called white area, yellow area, and black area. These are the three areas. Black area is nothing but what we have in any other foundry, but other two are very significant to last foam casting process. And this is you can see a cylinder black, a foam and the part, which is exactly the replica. Moving on to the next slide, there are various advantages of the last foam casting process. First is the design freedom, the complex multiple parts. If 2-3 parts are made today in any other casting manufacturing process, which are made one assembly after machining and sub-assemblies, those complex sub-assemblies can be made as one single casting. No draft angles required in this process. No multiple tools required like any other casting process. You see patterns, you have core boxes, and we have breaker cores, lot many. Here, only one tool is required, which is foam mold. And gating flexibility, gating can be in the picture like gating can be connected at the top or side or bottom or at the center. Wherever there is accessibility, we can connect the gating. And weight reduction feasible because there is no undercuts in this. Undercuts are permitted. So we can do weight reduction to the maximum extent subject to the design availability. And this process, we can save cost because 100% of sand can be recycled after cooling. No resins, chemicals required in this process. Lower tool cost because we don't have to make patterns separately, core boxes separately because there is only one tool required in this process. Higher yield because gating can be connected at every part of the foam mold. Because of this, we get higher yield, lower rejections because everything, the replica of the casting, we will see before making the casting. And lead times are going to be shorter because the tools are made in aluminum. Scooping aluminum is easier than steel and iron, and continuous production can be made. Moving on to the next slide, we can make a near net shape, weight reduction possible. We can make parts as minimum as 2.5 millimeter thickness wall. Eliminate machining elements wherever the tolerance is within 0.5 millimeter. The geometry is going to be very consistent. Very less variables because all the variables what we see in the casting can be seen in the foam. Foam can be corrected before we make actual casting. So foam can be even inspected. We can take a scale and inspect, or it can be done by CMM. Everything can be inspected before pouring. Flexible bag sizes, we can make either one piece or we can make thousands. And various parts together. In one particular mold, we can pour many parts together. So subjected to the material of construction is same, like one pump body, one pump housing, like one impeller, everything can be poured together in one mold box. That is the beauty of the system. Optimized cavities per box. As we know, it is like an investment casting tree. We can connect any number of cavities subject to the mold box size. Any casting holes which is over 5 millimeter diameter can be made as cast. If you see in the picture here, the holes in the flange. Normally, if you make a conventional casting, we are expected to drill these holes. The beauty of blast form technology is everything is made as cast. Even the 5 mm hole can be made as cast. Produce various variants, like normally in the pump housing there are various flanges, PN16, PN25, YANC 125, YANC 250. In that case, what we do is the flanges are made separate and glued. One flange glued to this body, another flange variant can be glued to this body, so that we can produce both the variants together, whereby even the tool cost can be optimized. It is a sustainable process with respect to the environment. And if you see, this is the beauty of the whole blast form technology. For producing 1 metric ton of casting, we need only 7 kilogram of foam, whereas to produce investment casting, we need 1:1. For production of 1 metric ton casting, we need 1 metric ton of wax. That is the delta in the blast form casting technology. Moving on to the next slide, the quality is going to be certainly much larger than any other casting process, because we don't use chemicals, no chemical, no gas defect, no blowhole, no gas. It is going to be a universal selling point. We can be a global leader if we have this technology. Tools can be transferred from other regions. Like customers say, I have a tool made suitable for blast form technology, which is in China. I don't want to invest tool again. Would you like to take the tool from China and start production? So if we have the capability, we can get the tool and start production. Unlimited tool life. Unlike the sand casting process, we have a limited life. Here, few millions, because there is no wear and tear, there is no abrasiveness in the foam beads. One foam, multiple metal of constructions. When the foam is made for one particular product, like say gray iron, where the contraction is 1%, suppose if you want to make the same product in ductile iron, where the contraction allowance is 0.5%, if we know in advance what are all the various materials we are going to produce from the foam, we can have a intermediate contraction allowance, which is 0.75. Even some foundries, they make steel as well. Like, the steel need over 2% contraction. Only during the tool design stage, we should know what are all the materials we are going to from the last molds, the foams. That is the advantage of this process. And we can produce the parts as small as few grams to a metric ton. So you can see, you can scale the size of the last form castings which are produced today. And the greatest advantage, another advantage is the molds can be placed in any orientation. Unlike sand casting, either it is horizontal or vertical, 180 degrees or 90 degrees. Here you can do 45 degrees, 35 degrees, any degree, whatever the orientation you feel, the foams can be placed. Minimum fettling, because there is no parting line, there is no draft, no flash, no core, no prints, nothing. So the fettling is going to be very, very less in this process. Inventories are going to be very less. We don't have to stock the sand, we don't have to stock chemicals, we don't have to stock various tools, we don't have to stock then further reduction of inventories. See, like we don't have to stock various flanges. Suppose the flange is PN16, we don't have to stock various flanges. So various bodies can be made together and flanges can be made separately and glued together. So whereby the inventories are reduced. Moving on to the major steps, we have, as I explained previously, we have 3 major steps. It is called white side, which includes foam molding and gluing, and yellow side includes coating and drying. Black side includes molding, pouring, and post-pouring process. You can see the weight of, suppose if you see the girl holding the foam, if it is a casting, it weighs not less than 500 kilograms. So that is the beauty of the system. Next is the dipping process and is a post-pouring. Post-pouring process is similar to any other casting manufacturing process. First, start with the tool design. The tool design is very, very important in this process. There are 2 significant processes in the tool design. One is a vertically parted molding machines. Another is a horizontally parted molding machines. This I am illustrating on the vertical molding machines. tool design for last foam is different from conventional sand casting process. Here we need a complete shift in understanding the entire process. The tool design is similar to investment casting process, only wax replaced with the foam. Tool is negative to produce positive profile. That is why the outcome of the molding look like a casting. Tool design parameters, the material of construction, mostly aluminum. The tool shrinkage allowance is 0.2%. Material shrinkage, like various materials, whatever you are intended to pour from the same foam, that shrinkage allowance also to be applied on the tool design. No undercuts in the tool. If undercuts are unavoidable, we need to introduce loose pieces. And slicing to be done to ensure there are no undercuts, and offset parting line. There are punch prints. The punch prints are the locators between the fixed half and movable half, and vacuum and steam venting to be provided to the tool. Foam injection locations, water spray nozzles, uniform wall thickness for uniform heating and cooling. The tool is expected to be having uniform wall thickness unlike any other processes. Moving on to the next slide. This is only for reference. The slice, suppose if you take a small pump body, it is sliced into two, slice 1 and slice 2. And when you make two slices, you can closely see there is a male projector and female for locating the foams at the exact orientation. And you can see the uniform wall thickness of the tool. And we have various parts in the tool, like this is a fixed half, this is a movable half, and they are locating pins and bushes. There is insert, there is a part cavities within this. In the tool, you can have multiple cavities, different products as well. Right, these are the vents which are inserted mainly for passing the steam and the water. And they are physical vents and they are micro vents. And you can see the gasket groove to avoid beads leakage from the parting line. Moving on to the next slide, we have pins and bushes. Is a back plate next to the tool. And this is a shooting gun which is connected, protruded towards the casting cavity. This is the design of the shooting gun. Again, it is sealed to ensure that no foam beads or steam is leaking from here. This is a water inlet, the diagram. And if you go to the side view, you can see how water is sprayed. And this is the area. So we need to cover the entire the foam cavity surface. So that is how the water injection to be designed. This is a typical spray nozzles. It is again customized to the casting cavity. This is called steam chest, is also a bolster. It will have various openings, one for the water, one for the steam, and one for the water and steam outlet. There is locating pins for fixing the tool. And again, there are gaskets to prevent the leakages. And this is the exploded view of the entire tool. Moving on to the, again, further exploded view. Two half of the mold supported by back plates. The entire assembly is again assembled into this chest or a bolster. So as I said earlier, this is a vertical automated foam molding machine tool design, and the tool design for the horizontal is going to be different than this design. This is only for the reference. If you, this is wherever there is an undercut, we can use loose pieces. And this is the simulation process. I have taken a flow 3D as an example because flow 3D done extensive research in the University of Alabama in last foam technology. Today, they seems to be the leaders in simulation for this process. So we exactly see foam residue concentricity and velocity in this process. The next one is now we are in white area. White area is nothing but which looks white is the foam beads preparation. There are two significant foam beads are available in the market today. The first one is EPS. The diameter of EPS varies from 0.18 to 0.8 millimeter. The carbon will be over 0.1%. It is suitable for gray iron, copper, and aluminum alloys. Similarly, STMMA, the size is a little larger and carbon is low as 0.06. It is suitable for ductile iron and steel. Steel again is not a stainless steel because stainless steel is sensitive to carbon. We can make carbon steels in this process. And the bead selection, normally the bead selection depends on the material of construction of the part. Generally 0.2 mm is used, which is like if you take a 1 liter jar, the beads weighs about 18 to 20 grams. The thumb rule is the bead size should be 1/10 of the casting wall thickness. If the wall thickness is 2 millimeter, then the bead size should be 1/10. It is 0.2 millimeter. So that is the thumb rule. And once the beads are selected, the next process is called pre-expansion or steaming process. So where the beads are taken into a boiler, steam boiler, and the steam is pumped for pre-expanding the foam beads at a half bar pressure at 100 degrees centigrade. And few electrical options also available today in the market. And the bead size will increase about 0.6. When you take 0.2 as the initial bead, after pre-expansion or steaming, the size goes to 0.6 millimeter. And after the cycle time again depends on the bead's quality requirement. It will vary 8 to 15 minutes. Once the steaming is done, then the third process is called ripening or aging. Bead aging, again, we have to transfer the expanded beans into a aging bins. They look like silos, storage silos with a lot of ventilation all directions, and approximately about 8 hours we are supposed to hang the beads in hanging silos after removing the superficial moisture. Dry on fluidizer bed for 15 minutes before transferring for the molding. Again we have to dry, then only dry expanded, dry ripened beads to be given for the molding. Bead size after the aging will increase to 1 millimeter. Here you can see 0.2 become 0.6, 0.6 become 1 millimeter. So beads keep expanding, depends on the process what we are processing now. You can see this is the EPS. When you burn EPS look like this, STMA may look this, and there are a couple of options, EPMMA, there are many foam beads are coming up now. And next process is the foam molding. The pre-expanded foam beads are expected to inject to the tool cavity. Once the foam beads are injected fully to the tool cavity, next we need to pump steam into the tool at half bar pressure for 2 to 6 minutes, depends on the part geometry. Once the steaming is over, next we need to inject cold water at 1 bar pressure for 2 to 6 minutes, again depends on the part geometry. This cold water, there are two advantages. One is to bring back the tool to the ambient temperature, and second is promoting the foam pattern ejection from the tool. After the cold water is pumped, then the foam patterns are ejected from the tool. Then foam patterns are collected by hand. Then tool is cleaned with a compressed air for the next cycle. The wet foams are dried in a controlled environment for removing the moisture. Normally, the foundry, they have dry rooms with a humid control. They ensure that the foams are completely dried before taking up for the next process. After foam molding, the next process is called foam assembly. The foam patterns are assembled together to form a full pattern with a glue. And again, in the glue, there are two options. Hard glue options are available and cold glue options also available in the market. Gluing can be done either by the hand or by the brush or by the gluing machines. Gating is assembled as per the method. So again, gating can be made because if you see the gating, we don't need surface finish. Gating not necessarily to be foam molded through the machines. It can be cut from a solid foam block. If it is, we need a higher precision or we need a more and more similar gatings, we can add another gating cavity in the same foam molding match plate so that we will get the gating as well along with the part cavities. And assemblies are further strengthened by adhesive tape or by the reinforcement. Here on the right, you can see two machines. This is a horizontal foam molding machine. In the bottom, you can see vertical foam molding machine. Moving on to the next slide, I have a small video on foam molding. The bee will be heated and expanded again. So the next slide is on the assembly sequence. On the top left, we can see the two separate foam are molded separately. Again, you can see closely there are male locator and other side we have female locators. This is a gluing gun. The gluing stick, it is called hot glue. We also can use a cold glue at the sealing joints, and then we need to take out the excess glue, and some suppliers like they apply adhesive tape as well. And further to now we can see a full form of the foam casting. Then gating is assembled, like you can see the runner bar and then necks, you can see risers as well. This is the beauty of system. In sand casting process, can you add riser here? No. So this is the beauty of the last foam technology. Moving on to the next slide, we have a video on so the next video is on the foam assembly. It is dipped into the glue tank. Okay, the next one, we completed white with the foam assembly. Then now we are in yellow area. Yellow area is nothing but the coating. Once the foam molds are assembled with the required gating and strengthened further by the adhesive tape or the reinforcement, now these are coated. If you see the coating specification, predominantly it is a water-based paint. The paint should be permeable so that it should be breathable, and it will act as a barrier between metal and sand, and it should be strong enough to hold the metal until it gets solidifies. The coating preparation and application, mix paint with the water to maintain required BAME. It is about 65 to 75, and stir continuously to avoid a lumps formation. Application, it can be done by the dipping or by the brushing, or even I saw robots. Robots are used for dipping the foams into the paint. And coating thickness, normally it is varies between 1 to 2 millimeter thickness, depends on the surface finish requirement of the casting. And in some cases, second and third coating also can be applied, depends on the surface finish and quality requirements of the casting. And coated molds again move to the controlled drying rooms in controlled temperature and humidity at 45 to 50 degrees centigrade. After this, you can see a foundry in China with lot of the foams. These are glued and these are coated. Next, black area, once the foams are made, getting assembled, coated, dried, and ready for metal pouring, comes to the black area. The major steps are like the mold box selection. We need to select the mold box which suits our part geometry. And we need to place the assembled trays into the mold box. We need to fill sand and we need to compact the mold box to ensure that the complete sand is packed. And we need to connect the vacuum and we need to pour liquid metal into the cavities. The mold box design should suit the part geometry or the tree geometry. And boxes can be any shape. Even I have seen round circular mold boxes as well. And sand parameters, it can be a normal dry silica sand, or we can use pile sand or any sand which granules about AFS number 40. No chemicals required to be added in the sand. 100% of the sand can be recycled after cooling and removing the fines. Next to this is a molding sequence. We need to fill the mold box to about 4 to 6 inches to create a bed. Once the bed is created, the assembled foams, now we can see there are there are 4 trees they are keeping in particular mold. Each tree is having 4 trees are 12. 48 castings can be made in one mold. That is the beauty of the system. And once the assembled foams are kept on the bed in any orientation, not necessarily we need to keep upside right. It can be 45 degrees. It can be in any orientation, depends on the sequential filling. Fill the sand with the shower type sand feeders for uniform filling of the mold. Ensure no deformation of the foam patterns while sand filling. Normally, when the sand is being poured into the mold box with velocity, the foams are likely to get disturbed. The position is likely to get deformed. That is, in some foundries I have seen they use some reinforcement to ensure that the foams are not shaking while sand filling. And next, while filling the sand, the vibration is switched on for the 3D compaction so that the sand get packed into the mold firmly. Ensure pouring cup is exposed for the easy pouring. Always we have to ensure that the pouring cup is exposed for pouring. And move filled boxes towards the pouring area. After this, the top surface of the mold should be covered with a stretch plastic film. Then the vacuum pipe is connected to the mold box and to create the negative pressure to the mold to 100 to 150 mmHg. This is mainly because to take out any fumes or gases or air in the mold between the sand particles, and also it will promote the mold filling. The mold filling is going to be much faster than sand casting because already there is a negative pressure created in the mold box. That is why even the casting is sound compared to sand casting process. Pouring same as any other casting process. Pouring temperature has to be about 30 degrees higher than sand casting process because the metal is expected to burn the foam. And I have few videos on this. Next one is the pouring, which is, it look like any other pouring process. Next one is the filling. So the recent developments, there is a supplier called Quanshai EPC is in Chinese, is a Chinese government company. They produce foams. You can see a lot of the cylinder blacks which are being sent to General Motors US for pouring. They make foams, they assemble foams, they assemble the gating, they pack and export to US for pouring. This is the recent development happening in China. Then if you see the environmental effect of the process, this, if you see the EPS contains about 92% carbon and STMMA contains about 60% carbon. Because of this, when you pour hot metal into the foam molds, the carbon monoxide which is generated, and we need to collect it carefully. We need to collect the fumes and we need to isolate them while passing through the wet scrubbers. If you see the overall impact on the environment is less compared to any other foundry process. Moving on to the next slide is the challenges experienced in India, because we're all in India. So these are the facts. It is my opinion. It may differ, depends on the people. It is not very popular in India, unlike China. Few foundries failed in establishing commercial production initially when we started the last form technology during early 2000s. And adequate research is not done on simulation. Not many equipment suppliers who can provide a complete solution. I have seen there are raw material supplier, they are equipment suppliers, but we need a suppliers who can do 360 degrees support for the foundries. Inadequate optimum tool designers or tool makers in India. Again, coming to the raw materials, quality beads and quality coatings are expected to be imported either from US or China. Another challenge is minimum order quantity, because we cannot buy 100 kilograms. You need to buy a container. Again, storage is a concern. Coming to the manpower is a big challenge today. The required competence is different, totally a different mindset of the people we need to handle the last form process. Due to very less foundries in India, hiring trained manpower is going to be a challenge. And if you train a fresh engineer, there is no guarantee that they stay with us. There is a flight risk. And biggest challenge I have seen today is unwillingness to share knowledge openly. If you see the graph, like we are the second largest casting manufacturers in the world. So I think as a foundry fraternity, I am looking forward that we work together to ensure that we beat China. Downside of the last form casting process. Like any other process, there are negative side of this process as well. Particularly when you look into the commercials, customers normally they say, I'll pay you by kilograms. Whatever the process you pay, I don't mind, not by the product. And the trained resources, we have to pay premium. Again, we need to import raw material. If you closely see the profiles, very small profiles, even the undercuts in the flanges are made in this process. That is the beauty of this. And unless we do the VAVE or change the design, it will not be economical. We need to do a lot of R&D as well. When you come to the quality, the stainless steel production due to carbon content is a challenge. And only EPS Elite, a company in Canada, started making the low carbon beads. Seems to be they are successful in this process. You can see a carbon defects in the cast surface. If you closely see, you can see a grains. They are likely to, when you do hydro test, the water is likely to leak from the porous. And you can see the defects. This is a copper alloy casting made through blast form technology. And there is a, you can see the vent marks as well. If you don't properly dress, we end up with vent marks on the cast surface. And foam beads and molds are like, we have to keep safe, otherwise they are likely to catch fire. These are the references, or I would say these are the disclaimer. all the information I have shared with the foundry fraternity today is based on my previous employment in this technology. And I did a lot of R&D. Almost 10 years I spent time in the last form technology. I'm lucky to work with the peers in the industry. You can see Marshall Miller, you can see Kevin, you can see Melissa from EPS Allied, you can see Gopeng is very popular in India today. So I'm only person from India joined American Foundry Society Last Form Council. And I visited many suppliers and customers who are in this technology. And I collected some information from the open source or the internet. AFS Last Form Council, I explained. I visited many foundries in China, maybe about 20 foundries in China, Canada, US, Mexico. Is all my limited exposure in this process. I'm sure the experts in the August forum, they are certainly more knowledgeable than me. You have to excuse me if I am wrong in this process, in the presentation. Thank you so much, team. And now the floor is open for the questions.
Thank you very much, sir. Thank you for a very interesting presentation. So, members, now the floor is open for questions. You may please either unmute yourselves and you can ask your questions, or you can type it out in the mail chat box.
Good afternoon, sir. I'm Benkappa here.
Good afternoon, Channagadra, sir.
Nice, sir. Nice presentation.
Thank you.
Very crispy and very informative. Thank you for that. Sir, I have one question. See, what is the yield expected out of Greer and SGR in this process?
Sir, the yield will be certainly about 5% higher than sand casting process. Because as I explained, there is a gating freedom. Not necessarily we need to connect gating at particular orientation. 360 degrees gating can be connected. And you can have a higher yield because we can connect the child parts to the same tree. We can optimize the tree, we can optimize the mold box, we can optimize the orientation. That is why my experience shows about 5% higher than sand casting process.
Okay, thank you, sir.
Thank you.
I think there is a question from PK. We are looking for steel casting by LFP. You can ask any questions from PK. I think they have just started typing. Or
Yes, very much possible. As I said, Melissa from EPS Allied, Canada, they have developed a foam beads within STMMA range, which contains a very low carbon. If you want to produce CF8M, which requires a 0.08 maximum carbon, I believe like one foundry in Karnataka, I don't want to name them today, they did the experiment. I can share it offline, not in the group.
Right, sir. So then there is one question from Mr. Panish. What should be the permeability of coatings?
See, it should be breathable. Permeability cannot be measured, as I have seen. It is measured by the specific gravity of Bombay 65 to 75. Because nothing to emit through the coating. The coating is mainly, there are two purposes of the coating here. If you see the coating is thicker than any other coating we use in the sand casting foundry. The purpose of the coating is to strengthen the mold, because you know the foam is very flimsy and very light in weight. That requires a reinforcement. The coating acts as a reinforcement. At the same time, because of the refractoriness of the coating, it will act as a barrier between the hot metal and the sand. So permeability is not that important in last form technology, unlike other processes.
Okay.
Good afternoon, Amle here. Can I talk to you?
Amle sir, why not?
Yeah. Sir, Venkappa sir, you asked one question about yield. Well, I was involved in developing a last form foundry in Maharashtra for 3 years. As Mr. Rao rightly said, because of the management's decision not to continue with that foundry is not working. But in that process, I have visited at least 10 to 12 foundries in China. They make motor bodies with 90% yield, 90 to 95% yield, right
Wow.
from 50 kg casting to 1 ton, 1.5 ton casting also.
Yes, correct.
Very nice process.
Mm-hmm.
And Srinivas Rao has mentioned all the points which are very, very relevant in Indian context. Lot of things are there. We can do lot of things, but yes, it should not be seen as a alternative to sand casting. It's a complete different process. We have to apply different mindset to that and take it forward. Because China, when I visited 4 years back, there were almost 800 different foundries working on this process only, and all the even the cylinder block head, then all manifolds, electric the bodies, compressor parts, even ductile iron parts, pipe fittings, everything is manufactured through this.
Amleji, today it is,
China use this technology very well.
Yes, today there are 2,000 foundries in China. I mentioned the Quanshai is a Chinese government technology company. They make the foams for General Motors USA. I have visited that plant. Amazing plant. They have about 25 foam molding machines, about 30 gluing machines, huge infrastructure run by Chinese government.
Right.
And they are supplying all the foams to US, General Motors US for casting it. Because the transporting foams are much economical. These are much lighter in weight. The cost of the transportation is much lower than transporting castings. That's what is happening in China today.
Right.
And one more thing, sir, Venkappa sir, when we met last time for Saurecon, you mentioned that this IIFX we are going to give some more attention to lost foam. If
Yes,
we
sir.
really do that, that will definitely going to help Indian foundries. Lot of people are there with some experience. If support is there to them, this technology is going to be a major technology. Lot of big casting issues like chemical sand, chemical resin, catalyst, dust, pollution control. Lot of things can be taken care of.
Sir, thank you, sir. Definitely, next IFX, Mr. Ankit Divakar is working on this project. So you will have exclusive corner for last foam process. Thanks for mentioning this in this good. Thank you, sir.
Yes, sir. Thank you, sir. Thank you.
I may add what Venkappa said. I'm SRV Ramanan here. We are going to have a live demo
Yes.
of the entire process from A to Z. And all the suppliers involved in the last foam process are also going to be there for any discussion. So as Venkappa said, who is the vice chairman of the 72nd IFC, we are going to have exclusive live model for LFC. We are going to really have a big corner for that.
Excellent.
Yeah,
Thank you, sir.
bit a pardon, myself Desh Kulkarni, and I work with the GST, that is Gujarat Metal Cast. So, Venkappa sir, if you can have a call with Mr. Tapan, who has worked for the LFC, so he will also throw some light in that.
Fantastic. Yes. Very good.
According to me, he is the best man in India for the last foam and the replica cast.
What is his name?
His name is Mr. Tapan Patel, good friend of mine.
Okay.
And this is only foundry in the world who produce ductile iron and stainless steel together in one foundry.
Wow.
And also
only foundry in the world.
Yeah.
What's the name of the foundry?
That is the Gujarat Cast, Baroda it is located.
Okay, fine.
Noted, sir. Noted.
Very good.
Thank you.
Thank you.
Any further questions, gentlemen, for Mr. T S Rao?
Sir, Mr. Rao, your presentation was excellent. In fact, you really, on a very interesting subject, everybody is looking for. Your presentation has been very good. We got a total insight of the process, and I think it has a very bright future, sir. Thanks for a wonderful presentation.
Thank you, Mr. Ramanan.
Gentlemen, if there are no further questions, we can move ahead with the vote of thanks, or if there are questions, we can wait.
Hello.
Yes, sir. Yes.
Sir, this is Mayur Acharya from Abhishek Alloys Private Limited, Belgaum.
Yes, sir.
We are about to install the LFC foundry. Maybe in another 1.5 to 2 months, we'll be able to install. So I just wanted to ask Srinivas sir, whether do we provide any consultancy, sir?
No, sir. I am working for a organization called Madras Engineering. We are not into
sir.
last form. I work for a sand casting foundry today. No, I am not a consultant.
Okay, sir. Fine.
Because
But
of
he
my
has wealth
previous
of knowledge.
association, with my previous exposure, when I worked with the previous organization, I was fortunate to expose to this. 10 years I did a lot of research, including the redesigning of the products. We produce parts like the casting weight is reduced by 30% because of the redesigning. We did a lot of research and development in many countries. And we designed a product, we call it as a Generation 5 pumps. Generation 5 pumps, the pump bodies are designed to suit last form technology only, so that the competitors cannot copy our design. That's what we did in my previous employment. Sorry to say I'm not a consultant.
No problem, sir. Thank you.
I am always open to share what I know today.
Sure. Definitely. Thank you so much.
Any further questions, gentlemen? Yeah, I think how many types of there's one question from Mr. Amit. How many types of sand used for molding across the world? I have heard silica, Al2O3 coated sand, hyaluronate sand. Please mention their advantages.
See, the sand doesn't have any role in the casting quality. The only requirement is it has to be the refractoriness, and the AFS number should be about 40. Because we don't use any chemicals, normally I saw in China they use pearl sand or robo sand or silica sand. And some of the foundries they use granules, the sand granules as well. There are many sands are used. Most popular the sand used is the pearl sand in China. In India we use silica sand about 40, AFS 40.
Sir, and then one more question from PK is how can we do risering in steel casting for this one, LFC?
See, the beauty of the system is we can connect risers in any direction, unlike the sand casting process. But only the disadvantage is we cannot use the insulating sleeves because of some limitations in the process. But the sand risers can be used in any direction, at any place, even inside the castings as well.
Hello, sir.
Yes.
Yeah, I have one doubt, sir. In this process, what is the rejection percentage, sir?
Again, depends. Can you say what is the rejection percentage in sand casting foundry? It varies. But compared to sand casting, it would be lower. Again, depends on the expertise we have in the process.
Okay,
there is no thumb rule.
Major defect, what the Srinivas sir has told, it is carbon defect and also the cooping, means if it is not properly tested, then that type of defect will come. So that training and required. So obviously rejection is very less in this process.
Right, sir. Any further questions, or shall we proceed to vote of thanks?
Somebody asked what is the die thickness. The die thickness expected to be about 20 millimeter, and the only limitation is the die thickness should be uniform, so that there will be uniform heating, uniform cooling. That is very important.
So there is also one more question. Which one for cooling is reusable, and percentage of water consumption?
Yes, it is like, see, water doesn't have any role other than cooling the die. We can use any water, but water should be cold, so that it will cool. The purpose of the water is only to bring down the cool temperature to ambient temperature. There is no other purpose of the water.
The surface of die is smooth or rough for the transfer heat?
The surface of the die is much smoother. Tie the swab is in the in the attendance list. He made a tools for a foundry located in US. He made tools in Pune and exported the tools to the foundry, last form foundry in US. The tool will be like a mirror finish. You can see our reflection.
Oh, okay.
Yeah, Mr. Rao, hello.
Yes.
Yeah, this is Sangram Tade from Alpha Dice.
Sangram.
Sir, hello. Sir, we just require some guidance with respect to venting. What is the importance? What kind of vents are used? And the afterwards, whatever dressing is required in vents. How do you take care of that?
See, the venting is like the venting what we use in the cold box process. Like in the cold box, we use vents, right? Brass vents. Similar vents, but there various design vents are available in the market. The purpose of the venting is to pass the steam. We need to cover the entire surface of the mold. And again, the purpose of the vent is to penetrate water to the mold cavity.
So
That comes
water
by
penetration
the
is
design.
important.
We have experts in this forum like Sanket. Hope Sanket is there. He is the best designer of the last foam tools in India. Sanket, you are there, right? We have Mr. Sanket. He is an expert.
Yes, thank you, Rasa.
Thank you.
Any further questions, gentlemen? So if there are no further questions, we'll move ahead with the vote of thanks. So friends, today we have had a very interesting webinar on the topic lost foam casting technology. This was our 43rd program conducted by the Institute of Indian Foundrymen Chennai chapter. We are sure the contents of the talk had a lot of takeaways for our audience. It was indeed a very important program on a very trending topic and very well conducted by Rao sir. Thank you, Rao sir, for your time and taking off your time and making us rich with knowledge. It was a very fantastic presentation with a lot of pictorial representations, and it was very much commendable, sir. Thank you very much. Excellent. Further, we would like to thank all the members who joined us for this talk. I'm sure you had a wonderful learning experience, and thank you for joining us on time and being such a wonderful audience. We from the Chennai chapter will be conducting many such interesting programs, both physical and virtual, and we will be sharing information with you all soon. Looking forward to seeing you all in our upcoming programs. Thank you very much, sir. Thank you.
Thank you, IIF, for giving me the opportunity for presenting. Hope I could do little awareness program for the interest of Indian Foundrymen. Thank you so much. If somebody have any questions, I could see still questions are coming up. The questions can be routed through IIF Chennai chapter. I'll be happy to answer them one-to-one.
Okay, right, sir.
Thank you.
Thank you, gentlemen. Thank you so much.